Okay, in this video, we're going to go through the Chapter 6 test review. So the first question says, list all pairs of congruent angles and then write the ratio of the corresponding sides in a statement of proportionality. Okay, so here is your similarity statement right here. Okay, so we're going to use this. And based on that similarity statement, I know the following angles are equal. Notice they are not similar, they are equal. So I'm just using the similarity statement that I just circled to pair up my angles. Okay, so that's the first piece of this. Next, they want the corresponding sides. So let's grab the sides. So the sides, using my similarity statement, the first pair is AB. That goes over the first pair, DE. Then I say equals. Notice I don't say similar, I say equals. And then I'm going to say BC over EF. And then I'm going to say AC over DF. And I am done. So looking at the next one, it's almost the same thing, but you're going to very carefully use this similarity statement. So the angles this time are angles A goes with angle D, angle B goes with angle F this time, and angle C goes with angle E. Again, use your proportionality statement, or excuse me, use your similarity statement because it makes it easier than trying to look at the shape. Okay, then you're going to do your sides as a proportion. So AB is to DF, just like BC is to FE, just like AC is to DE. Okay, and those two are done. We've done a lot of practice with that, so you should be actually pretty good with this. Okay, so now it says determine whether the polygons are similar. So to determine, when you're given all four sides, first off, check your angles. Because your angles are all exactly the same, that's the first condition that I've taken care of. So now, because all the angles are the same, it's a good candidate for similarity. Next thing you're going to take, since there's only two sets of numbers, take the biggest number on the left. 8 is to biggest number on the right, 6. Just like maybe, go for the smaller number on the left. 6 is to go for the small number on the right. Now right away, I know this is not true, because look, if I reduce this, 6 over 3 is 2 over 1, and that does not equal 4 over 3. So since they are not equal, these are not similar. Okay, what else could I have done? I could have done the cross product. And if I do the cross product, 8 times 3 is 24, and 24 does not equal 6 times 6, which is 36. So since the cross products don't equal, that's more reason to say these shapes are not similar. Okay, moving on to the next one. Check your angles. Okay, my angles all pair up. So that is one of the conditions of similarity. All the angles have to be congruent. Then we're going to check the ratios. They have to be the same in all three cases for this to be similar, for these to be similar shapes. So take the smallest, or the baby one on the left over the baby one on the right. Does that equal the medium-sized one on the left over the medium-sized one on the right? And does that equal the big one on the left and the big one on the right? Okay, I can reduce all of these. 3 goes into itself once. 3 goes into 6 twice. That's 1/2. 4 goes into itself once. 4 goes into 8 twice. That's also 1/2. 5 goes into itself once. 5 goes into 10 twice. 1/2 are all equal, and that is the scale factor. And therefore, I could put the similarity statement between them because these guys are similar. Okay? Okay, let's go to the next page now. Okay, now they tell you that they're similar, and you need to find a missing x. So let's see if we can get a scale factor. So ST, which is the 6, goes with PQ, which is the 4. 6 over 4 can reduce to, if I put 2 into both, 3 over 2, and that equals the scale factor. Okay, use your scale factor, 3 over 2, to figure out what goes with x. So x is going to be on the bottom. X is PR. PR is the first and last. That's going to match up with SU, which is 12, which goes on the top because that goes with the triangle on the left. Okay, do your cross products. So this is a cross product because one fraction has to equal the other fraction when you have shapes that are similar. 2 times 12 is 24. 24 equals 3x. Divide by 3, divide by 3, and x equals 8, and we are done. Okay, the next one says find the scale factor, so that's our first job. Okay, I only have a 12 over here. So PQ is the 12. So that goes with LM. LM is the 9. So go to the left triangle over right triangle will give me my scale factor. Divide both by 3, and you get 3/4. That is your scale factor. You have to have the reduced terms, right? Okay, now next thing. Then find the perimeter of each figure. Okay, I'm going to find the perimeter on the left. They all have numbers on each of the sides. So I'm going to add up 9 and 15 and 21. And when I add that up, I get 45. So 45 is my perimeter. I'm not sure what this is. I'm just going to call it P. I am not going to try to figure out the other two sides. That's a waste of time. Instead, I'm going to use the scale factor. The scale factor is in the same proportion as the perimeters. That allows me to do my cross products. And I say 3P equals 45 times 4, which is 180. Divide both sides by 3, and you get perimeter equals 60, and we are done without solving for this or this. There's no requirement to do that. I would not recommend you do that. It takes more time, and it doesn't demonstrate that you understand that the scale factor can be used to relate perimeters. Okay, are the triangles below similar? If they are, write a similarity statement. Okay, we know what those are. And then state whether you are using AA, SAA, or SSS similarity. Okay, I am seeing that these two angles are equal. So I'm going to see if I have proportionality, and I am looking at side angle side. So take the smaller of the two values on the left and put it over the smaller of the two values on the right. Does this equal, and we're going to pick the bigger of the two values on the left over the bigger of the two values on the right. Now let's just say I don't feel like reducing. What could I do to check this? If these are indeed proportional and these fractions equal each other, the cross products will be equal. Go ahead, 4 times 12, 48. And 3 times 16 is also 48. So that means that these guys are in proportion, and I have SAS similarity. Okay, now I'm going to write my statement. Now you've got to be careful because I'm going to go down the small side and start out with triangle JSA. LK. Okay, I went down the small side to the 85. So go down the small side to the 85 on the other triangle, and that's going to be triangle YXZ. And we are done. Okay, this next one, what I see is I have vertical angles. I see that right away. Here are vertical angles. Then, because these guys are parallel, cut by a transversal, I can say that this angle and this angle are equal because of alternate interior. The second I have two angles equal, I have AA similarity. Write your similarity statement based on the angles. So I'm going to go from the W to the Y and then around to the X. I'm going to follow the same pattern. Go from the V to the Y and around to the Z. And that is my similarity statement. Okay, bringing us over to 9. Similar work. Are the triangles below similar? If they are, write a similarity statement and state whether you are using AA, SAS, or SSS. Same thing I just did. When you've been given angles, always find the missing angle because you know you have 180 degrees inside. So do that subtraction and you get 72 over here. And doing the same thing because it's another triangle with 180 degrees inside, this becomes 82. Do you have two angles that are identical? It looks like I only have one angle. That is not enough. These are not similar. This brings us to 10. Again, you have some missing angles. The triangle on the left is an isosceles triangle. With an isosceles triangle, you have equal base angles. Then use the fact that you have 180 degrees inside to figure out the top angle. That top angle is 38. Okay, look at that. This top angle is 38. And this is also isosceles. I now know that these guys have to be 71, just like the triangle to the left. These guys are similar based on angle similarity for one. But guess what else? Because I have proportionality, because they're both isosceles, I could also use side angle side similarity. And I probably could use side, 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 but I don't want to stretch that out. So I can use these two similarities. Write your similarity statement. I'm going to start with the base angle. NMO is similar to PRQ. And we're done. Okay. Now for this one, you're going to complete each statement. So what do I know? First off, I look at this and I see angle equal, angle equal, angle equal, angle equal. So by that, I know I have a AA similarity. So I can now write my similarity statement. It's half done for me. Since they started with A, I'm going to start the second triangle with D. Since they followed with B, I'm going to go to E, and then I'm going to come around to F. Okay, so they're trying to do our proportions with us. So AB goes with DE, and EF goes with BC, and CA goes with FD. Okay, now they want to figure out what is your missing values. I have two sets of them. I have X plus 1, so the X is missing, and I have Y. So using your similarity statement or your proportionality, get your scale factor. So what do I see? 6 is AC, and AC goes with FD, so my scale factor will be obtained by taking 6 over 16 and reducing. I can divide them both by 2. 3/8 is my scale factor. Okay, to get x, I'm going to use my scale factor of 3/8, and I'm going to use the proportionality of x plus 1 over 12. Cross products. That gets me 3 times 12 is 36 equals, very carefully, 8x plus, not 1, plus 8, because that 8 goes to both the x and the 1. Subtract 8, subtract 8. That's going to give me what? 28. 28 equals x8. It's not going to be a whole number, but that's okay. You can put it in your calculator, and you're going to get x is 3.5. So this is 3.5. Now we're going to go ahead and get the y in the same fashion. 3/8 equals, what goes with the y? 8 goes with the y. 8 times 8 is 64 equals 3y. Divide, and when you put that in your calculator, you'll get 21.3, and then that's continuing forever and ever, so I put the bar notation above it. Okay, so we're done there. Okay, now we come here. Are these triangles similar? And if they are, find the scale factor. Okay, so far they have the same angles, so let's go big on the left over big on the right. Does that equal small on the left over small on the right? Let's see what we want to do here. I just went ahead and I checked the cross products. So if I multiply this times this, I will get 336 equals 336. Bingo. I have proportionality because those two fractions are equal. So I can take one of them now and reduce it. So if I put a 3 in the numerator, I get a 7. If I put a 3 in the denominator, I get a 4. And that is my scale factor. Okay, continuing on. Look at the next one. I already have the angles equal. So then say small over small. Does that equal big over big? Again, I'm going to do my cross products. 36, does that equal 9 times 4 is also 36. Yep, they're equal. I have proportionality. Take one of these and make it into a scale factor by simplifying it. 2 goes into 4 2 times. 2 goes into 6 3 times. That is my scale factor. So I can go back and do similarity to both of those. Okay, that brings us to 14. And looking at 14, they have all the same sides. So to check it, I have to say small over small equals possibly medium over medium equals possibly big over big. Looking at those, I can pretty quickly see that I could reduce all of them to 3/2. So I have similarity, and here is my scale factor. Now I have been talking pretty quickly just to get through with this video, but you can slow it down and you can stop and think about each of these problems, and I would highly recommend that. Okay, this last one is also all sides. You've got to check all 3 proportions for possible matching. So small over small, does that equal medium over medium? And does that equal large over large? Well, looking at these, I can reduce all of them to 3/4. That's my scale factor, and these guys are similar. Notice I'm circling the scale factor. Okay, look at these two. They're asking you if they're similar. If so, state the similarity and the postulator theorem that justifies your answer. So these are isosceles. I'm going to say bigger over bigger, does that equal smaller over smaller? If I do cross products, which is the easiest way for me to check, I do have that. So they are similar. And they're similar. I have all the sides. So they're similar by side, side, side. And I can write a statement. So I'm going to say base angle BAC is similar to base angle YXZ. Okay, so I have everything there. Next one, I see I have an angle, so it's possibly SAS. I go small over small, and I check whether that's equal to big over big. They both reduce to 2 over 1. They are indeed similar, and these guys are similar by SAS. Okay, what are the 3 theorems that we've been using? Either angle-angle similarity, and I'm going to write sim next to it, or side-angle-side similarity, or side-side-side similarity. That's what we've done so far. If we know that 2 triangles are similar, what do we know about the corresponding angles? So I'm going to say corresponding angles are congruent. If we know the 2 triangles are similar, what do we know about the corresponding sides? Corresponding sides are in proportion. Okay, those are your ratios. Okay, now this is from 6.5. We know that this is to this, just like this is to this. So 12 is to 36, just like 9 is to X. I put 12 in 1 time, 3 times. X is going to be 27 because 9 times 3 is 27. Done. So these were parallel lines in a triangle theorem that we did here. Next one, I know that this is to this, just like this is to this. So 8 is to 10, just like 16 is to X. Okay, 2 goes in here 4 times and 5 times here. So if I do the multiplication, I will get 5 times 6. What is that? 4x equals, that's 80. So x has to be 20 when I divide and divide. Okay, last one. I know that this is to this, just like this is to this. So I can say 28 is to 8. Just like x is to 12. Okay, 7 goes in here 4 times. I'm sorry. Do I want to do that? Yes, but that's not going to help me. So let me not do that. Let's back out of there. What do I want to do? I want to, put 4 in here. 4 goes into here 7 times. That's what I want to do. 4 goes into here 2 times. I'm reducing it to make my numbers smaller. Do your cross products. 2x equals 7 2s are 14. That's 84. Divide by 2, and you get x equals 42, and we are done. If you can do this, you will be highly successful on the upcoming test. Thank you for listening.